Okay. Just a quick reminder. Again, I don't know, Michelle, if you have in your OneNote, the final exam. In my Schoology folder. In Messenger and Kolobeckia's OneNote, you guys have a final exam review tab. Mrs. Kolobeckia and I went through and made a Quizlet. So for those of you in Global who like studying all your words or Spanish or whatever you guys use Quizlet for, we have everything in Quizlet for you. So if you don't know what standard form of a polynomial function means, that's one of the vocab words. You guys have a week until the exam, okay? This is so valuable when you guys are out of school after Friday to Wednesday. How can I study for this exam? Get on Quizlet. Learn those vocabulary words. On top of that are all the answer keys for everything that we've done during review time, including the in-class stuff, the vocab day multiple choice, the calculator day multiple choice, okay? All the after-school reviews. So if you know last week you didn't make it to the exponential functions day, it's in there. Utilize this tab to study things, okay? And then I think even these ones have this one has the completed notes, but it has a blank copy of the work. So you can always go back and redo the work with that blank copy, okay? All right. So now today is solving functions, okay? So we're gonna hit a bunch of different types of functions today. Linear, okay? Linear equations, linear inequalities, systems of equations, and quadratics. And quadratics is kind of one I feel like during review, students do not remember how to solve quadratics. So today's a really good day to come to. Okay, so first we're just gonna start with something, this is what we started the year off with, okay? Solving equations and inequalities, okay? So these right here are just the steps that are used in order to solve. The draw the railroad tracks, that's obviously up to you guys and what you've been taught and what you're comfortable with. So I'm given this and it's an equation. I draw the railroad tracks on the equation, okay? Then, so what's something in the equation that stands out to us as something we need to take care of? The parentheses, okay? And what's it called when we do that? It's called distributing. And what operation are we doing? Multiplication. This is a common multiple choice question with what was just performed, the distributive property, okay? So if those parentheses are disappearing, it's because the distributive property was performed, okay? So 2 times 5 would give me 10. Now this one has variables on both sides, okay? So I want to try to get all the variables to one side, all the numbers to the other side. So what do we want to move? Yeah, subtract the 2p. Now some people, maybe that's not what you meant. You could also subtract the 2. Okay, that was the other option. I usually like to do the variables first. Yeah, not meaning that you can't do both. So here I get 2p plus 2 equals 10. And then, yes, you could also subtract the 2. Okay, either way, our goal is to get what alone? P. And then what do I do with the 2 in front of the p? Divide. So a lot of it was just rearranging things by using inverse operations to get p alone. That last step, though, remember, we're dividing by the number in front of the variable. Sometimes we have students that subtract. You're only subtracting is if you have an addition problem, okay? You add if you have subtraction, but if you have multiplication happening, you get rid of that, you divide. So I get that p equals 4. You could always use your calculator to check whether you got the right answer, okay? Plug p back in or type these into y equals and see at 4, do they equal each other? Anything to add there, Mashenik? Okay. Biggest thing about, so this was an equation, guys. There's an equal sign, okay? I don't know if this looks familiar to any of you, but on your mock multiple choice exam, it wasn't an equation. It was the very first multiple choice question, and it was an inequality. What I've noticed is a lot of students, as they go through and solve inequalities, for some reason at the end, you put an equal sign instead of the inequality symbol, okay? Keep your symbol the same. If, however, it is an inequality and you do divide by a negative number, you got to remember to flip the direction of the sign. So if you write it as an equal sign, you completely lose the inequality and then you get it wrong, okay? So it's very important that you're paying attention to whether you have an equation or an inequality. Also, today I think you guys experienced this question, at least with Shenik and Messenger students, but you guys solved an inequality today that had to do with either finding the largest or smallest integer solution. And you have to ask yourself, what's the first integer that will work in the inequality? So for example, we wanted to know, I think today was something that was greater than -1, the smallest number greater than -1. This one wants to know what's the largest possible integer where the inequality x is less than 15. So give me the first number that works that's less than 15. 14. There's obviously other numbers that work, but 14 is the largest one that it could be. Okay, so my answer here is 14. If this had a line underneath it, what would that imply? Which means what's my largest answer? 15. But because there's no line underneath it, it has to be less than 15. So 14 is that first number. Okay. If the answer is a decimal, okay, you have to then pick an integer. Okay. So for example, if I want x is less than 5.2. Okay. You guys see how it's a less than symbol? It means you want to go down, but it's got to be an integer. What does integer mean? Means no decimals. I just made it up, yeah. Okay. So some of you who went down to 5.1, right idea, you went less than it, but keep going because it's got to be a whole number. So what would it be? 5. Okay. So here 5 would work.
What if this was like a real world situation about, I don't know, I can't think of it. But it said the final thing was not x is less than 5.2, it was x is greater than 5.2. What would our, like, the next, what would the smallest integer be? 6.
It would have to be 6. Right. Go ahead.
5.2, you think, oh, I have to round it down. Remember, it's got to be greater than 5.2. Okay. That part is well.
But again, you have time on the exam to kind of really think about it in the situation. Okay? If I put that as a 5 in terms of a rounding scenario, oh, 2 doesn't round 5 up to 6, and you pick 5, 5 is not greater than 5.2. So that's what these little rules are too. If it's a less than symbol, you want to pick the number that's less than it. If it's a greater than symbol, you want to pick the number above it. It's not about rounding. It's about just what solution works in that situation. Okay. So here's an example where it's asking for the smallest integer that makes this statement true. So let's again do it by solving. And again, notice we're given an inequality. Do not lose that inequality symbol as you're solving here. Okay. So I look here and I want to again get x alone. What do I see that's standing out here about trying to get x alone? There's 2 x's. They're on the same side. So this is where railroad tracks also is important because railroad tracks help determine which side the variables are on, and they're on the same side. So I don't have to use inverse operations to move things around. I can just combine them. Okay, so what's -3x and -5x become? -8x. And then I bring down the +8 is less than -25. I didn't lose the inequality. I brought it down in the next step. If you guys remember to bring down the inequality every single step, you won't lose it. Okay? Some students just don't bring it down, and then at the end, they just, out of habit, write equals. Okay? So then what's the next step here? Subtract 8. -8x is less than -33. Which some of you might be thinking, well, that's not really going to make sense because it's going to be a decimal, but it's fine. I think there was a point being made here. Couple points. I divide by -8. I switch the sign. Good. Okay, because I divided by a negative. And what's -33 divided by -8? 4.125. Did I hear that right? So this is Shenik. This is the example that you were thinking about, right? Not context, but you guys look at 0.125 and rounding wise, it wouldn't round up to 5, but I have to pick a number, the smallest integer that's greater than 4.125. And what's that value? But 6 works, but it's not the smallest one I could pick. I could go lower than 6. I could go 5. Okay? Why not? Yeah, I can round up to 5. 5's the next one that works. So that's what this question's asking. It's saying, what is the first integer that will work in the inequality? So when you think about the first integer that follows this, 5's the next thing that follows after 4. So that's got to be the one that works. It's the one that's next to it. So you don't have to make this big jump somewhere else in terms of a solution. This could be like how many hours you need to work to make enough money to buy something, right? I wouldn't have enough, but they'd have to work that extra 5th hour to make sure they have enough. That's what we did that in the beginning of the school year, okay? So again, you guys have solved the equations and inequality since then, but again, that was in the beginning of the year. The next one's talking specifically about functions, and when I look at solutions, when I'm basing them on graphs, okay? So when you're talking about just a picture of a graph, where do we find solutions? On the line, okay? So if it's just a single linear equation, or any equation for that matter, if we're talking about a solution, it's any point on that line, okay? So for example, so a common question is, which point is a solution to this equation? Or which point is not a solution to the equation? So that's why Ms. Shennick's bringing up the table, that you would be able to see that 2, 3 in the table as well. Also found in the table. Inequalities add another component to it. It's not just about on the line, but where else? Where else can I have solutions to an inequality? In the shaded region. By the way, what way is this inequality facing for this one? It's facing down, so what inequality would be used? Less than. So this is a less than inequality. What type of line do I have here? Solid. So it also has to equal to. Good. Okay. So that's a decision you guys have to make. You see that inequality symbol? You see that inequality symbol, and you got to kind of know what inequality symbols go with which lines. Systems of equations. So actually, let me add this here. So this point right here is in the shaded region. So 3, -3 is a solution. Okay, because it's a solid line. Hang on, let me change my color. Because it's on a solid line, any point on that line would also work. Okay, so 2, 0 is on the line, but it works because it's solid, meaning it can equal that line. I love the encouragement, Tavon. It's really making me feel good. Does he do this when you're teaching? Systems of equations. So how many equations do I have for a system? 2. Okay. So here, this is an example of a quadratic and a linear system. And how many times do they intersect? 2 times. Those are your solutions, where they intersect on the graph. Okay, you might have 1 point of intersection, 2 points of intersection. Sometimes they might not intersect, okay? Sometimes they may lie right on top of each other, and then how many solutions do you have? Infinite, good, okay? All the possible solutions. So it could be anywhere from 1 to infinite solutions. It's about where they intersect with each other, okay? So -3, 4, and 2, 1 are solutions. A common thing that the exam likes to do, and again, this is a reading thing, is sometimes they don't care about the points of intersection. They just want the x values of the intersections. So what are the x values here of where they're equal to each other? X equals -3 and x equals 2. So you got to read.
It just means where the first equation equals the second equation. Yes.
Right, yeah. Where do they equal each other? They equal each other at their intersections. Okay? All the other points are different from each other except those points. Okay? So this is graphically. Graphically is nice. You most likely will graph it, see where they intersect, identify the solutions. You'll also find that there are points in common in the table. When you're asked to solve a system algebraically, we use a process called elimination, which is the idea of finding 0 pairs, eliminating a variable, and then combining the 2 equations together. Okay? So I feel like, again, I don't know if you can speak to this, Ms. Shenik, but my students really kind of forgot about the idea of elimination when it came time for the exam and thought, oh, I'm going to solve this for Y. I'm going to solve this for Y. And then when you solve them both for Y, you're like, oh, I don't know what to do now. Okay. So it's not about solving for Y. If you're ever given a situation where you're not graphing them and you just need to determine the solution for X and Y, you use it algebraically elimination. What does it mean, zero pair?
They equal zero when you add them together. So like, yeah, they cancel out. Two numbers that cancel out, right? Like 7 and negative 7. That's what a zero pair. Yep. Yeah. So what I always like to do to try and find it, because I feel like that's the hardest part, is I say, okay, this one's got a coefficient of 1, 1 and 2. Do those go easy together? Yeah, 1 times 2, I would get 2. As compared to say 3 and 4. You know what I mean? 3 and 4 don't go well together. One doesn't multiply to the other.
Right. Can I turn one into the other or make them the same number easily? So what Ms. Jenik is saying is 1 can easily be turned into 2 through multiplication. So it's important that you're doing it through multiplying and that you multiply everything by that value. So I can turn this into a 2 by multiplying by 2, but they wouldn't cancel out unless what's happening? It's negative, right? So remember, the idea of the zero pair is that they cancel out. They have to be opposites in order to cancel out. Some students, in my class, we talked about this idea of the flip-flop method, which is the idea that if you just don't know, multiply each equation by each other as long as they end up being different signs. So I can multiply this one by 4 and this one by 3. Okay, and again, you got to make sure that they're different signs. If they're not different signs, they don't cancel out. I think this right here would be the easiest way to do it, turning the X value here into a -2. If you guys are comfortable doing something different, go ahead and do something different. So I'm going to keep the first equation the same. I didn't do anything with it. You don't always have to do it to both. And then the bottom one becomes -2x minus 8y equals -28. Very important that you multiply everything through. When they ask you the questions about which choice doesn't give you the same solution or which choice gives you the same solution, it's about looking at the process and saying, oh, it was done correctly. Okay, and a lot of the times what happens is the multiplication, there's an error in the multiplication, and that's why it's not the choice. Okay, so there might be an error in 3 choices and only 1 works, or vice versa.
So like they would say that the second equation would become -2x minus 8y equals -21.
A mistake was made, right?
You know what I mean?
Okay, so look for that mistake. If mistakes are made, it can't be the answer unless it's asking for which one doesn't work. So again, that's a big thing on reading, guys. You guys have the time to read carefully, read carefully. So now I'm adding them together. What happens when I add these together? They cancel out. I'm left with -11y. And this is another big thing. When my students were doing these, assigned numbers were a huge thing in terms of remembering that it was a negative number. So take the time, again, on your test, to type this in and do -3 plus -8. Okay, it gives you -11. What's -16 plus -28? -44. That's looking pretty good. Divide both sides by -11, and I get y equals 4.
Now, guys, would it be okay to get a decimal answer? Yes, that is okay. That does happen. Usually when you've got like a story of context.
Right, like if you're solving for the cost of an apple and the cost of a peach or something like that. Okay, it's okay to get decimals. So you just got to be aware of the context you're in. We are not done though. We have solved for y. What else do we need? X. You do not. Yeah, you do not need to do the elimination process again, okay? You just need to take the y equals 4, pick one of the equations, and solve for x. I actually like the bottom equation. One, there's less negatives to worry about. I'm not going to even write the 1x because that wasn't the original in the original equation. Bottom or top, okay? And again, it's if one stands out to you as you think it's going to be easier, or maybe you just always pick the top. Always pick the top, okay. So I'm substituting y as 4. I put parentheses around my substitution. And then it's just a matter of simplifying, okay? Meaning, what can I simplify in this step? The 4 and the 4 become 16. And now how do I solve for x? Subtract 16.
I'll tell you what, guys, I was really impressed with you this year. We did fantastic with this part.
Yep.
And then all of a sudden, when it got more basic, right? Like when this is just a one-step equation or a two-step equation, we all of a sudden forgot how to do basic algebra, how to solve an equation. Okay.
But again, it's just looking at what's the end goal here. The end goal is to get x alone, right? And I have this stuff happening to x. How can I simplify it or cancel it out, okay? So my final answer, remember, is an ordered pair, x comma y. So my final answer is -2, 4. If it was a context situation, you obviously want to address it in context, meaning this is what x stands for, this is what y stands for, okay? Negative wouldn't make sense in context, but really quick, last thing, well, at least with graphs, systems of inequalities, just like with equations where the equations overlap, where they intersect, what else is intersecting besides the lines? The shading, often indicated with a giant S to indicate that's the solution. So where this shading is crisscrossing, that's your solution. Any boundary line to the solution, to the S area, the shading, is also considered a solution, except if it involves what? The dotted line. So like
So
this.
here, the
Yep.
intersection point, would that be a solution?
No.
Because one of them is
Anything on this solid line here, because it's bordering the solution area, would count, but anything on this one over here wouldn't work, and any of these outer areas wouldn't work because they're outside that intersection. So this right here is just reminding you that points that intersect two solid lines, solution or not a solution? Solution. A dash line and a solid line where they intersect, not a solution. And two dash lines, absolutely not a solution. Double not a solution.
When in doubt, guys, just any point in the double shade area.
Yeah, don't
even worry about the line.
right. You push the limits, right? By picking something on the lines, just go. What I smack dab in the middle of the double shaded region. Smack dab. I actually had a student write that on smack dab.
Oh wait, never mind.
Okay. If you are asked to write a system of equations or inequalities, you need to have how many variables and how many equations and inequalities? 2 variables, which means how many equations and inequalities? 2. It's very important if it's asking for inequalities, you actually write inequalities. It's important if it's asking for equations, you write equations, and that there are 2 of them. If you have done a weekly recently, weekly number 5, I think week number 5 or 4, this was asked on it. This was also the 6-point question, the part 4 question on the June exam last year, okay? Most likely the part 4 is going to be some sort of system. Usually, there's been rare cases where it hasn't been, but it's been a very common thing. So Dylan has a bank that sorts coins as they are dropped into it. A panel on the front displays the total number of coins as well as the total value of these coins. The panel shows 90 coins with a value of $17.55 inside of the bank. If Dylan only collects dimes and quarters, write a system of equations in 2 variables that could be used to model this situation. What do we always say about money? Money plus money equals money.
Now, wait a second. I only see one money here. Yes, I do. I only see $1 sign.
Where's the dollar sign? Okay.
Well, it tells you at the bottom that dimes and quarters.
But yeah.
Dimes and quarters have money value, right?
That is correct.
Where am I going to put the 755?
And the equals.
At the equals. So 755 would be my total. Now I'm adding what together to get that total? But it's about the money that I earn from dimes, right? And the money that I earn from quarters. So what's the money I earn from dimes? Well, how much is a dime worth? 10 cents. Okay, here we go though. How do I write 10 cents as a dollar value? 0.10, 0.10 dimes. So my students, at least when I was grading them, some students just write 0.10 plus 0.25. You have to have variables, okay? It's 10 cents per dime plus what per quarter? 0.25 Q per quarters. Yes, we've already done this.
How would we write it if it was nickel? Is it 0.5 or 0.05?
0.05. 0.5 is 50 cents, okay? Okay, how many equations have I written? One. I need two. So again, Ms. Shenik, right? So that other is that the total number 90, I only see one value. So a lot of times when you only see one number, students are like, well, where's my other numbers for the equation? Sometimes it's just adding the variables together. My number of dimes plus my number of quarters equals 90 coins. I don't care about the value of the coins. I just want to say I counted that many coins. So you might have one where there's no numbers, but it's asking for total value. Just add the variables together for the total. All right. Lastly, quadratic functions, solving them algebraically. Okay, well, first, guys, I'm almost done, almost done. When you are asked to solve quadratics, okay, we're talking about when y equals 0. When you solve quadratics, you set them equal to 0, okay? You could also be asked to find the roots, the zeros, the x-intercepts, okay? This got brought up yesterday with quadratic functions, but it's about where it crosses the x-axis. Does this cross the x-axis? So it does not have what we call real solutions. How many times does this cross the x-axis? So it has one real solution, this one, 2. And again, I'm looking at where it crosses the x-axis, okay? So step 1 is setting it equal to 0, okay? That's a big thing. Some students forget to do that, which then messes up the quadratic formula. Where is this provided to you on your exam? How do I know that I even have to use it? So 1, it's saying solve. 2, I don't have the equal 0 here, but what type of function am I given? Quadratic. How do I know it's quadratic? Because of what? Because the exponent of 2. We went over this with the quadratics yesterday. Okay? A lot of you want to solve these like a linear equation. It's not linear. So you can't isolate the variable. You can't move things around and say, oh, x equals this. It's different. So once you recognize it's quadratic, okay, our first step is to set it equal to what? So I add 9. A lot of the times when you do that, it's not going to combine with anything. It's just about moving it over so that it's on the same side. Yes. So you're saying to me, just know when you go do the formula, it's going to switch to a positive 9. Yeah. Right. Yeah. Like there was a one on our classwork today where it was a 7 and it had to be subtracted over to be -7. What's the next step after getting it set equal to 0? What is A, what is B, and what is C? So very important, it's alphabetical. It's your A, B, C's. There's 3 numbers there, okay? It's not about variables. You do not want to plug variables into the formula. It's going to screw it up. So what's A? B? C? 9. Other important thing, if there is a negative, do not forget it, okay? Because again, that's going to throw you off. Next thing, some of you might jump right to your calculator and start by saying, I'm just going to go type this in my calculator. If you do not show the substitution into the formula, you're going to lose credit for work. Even though you have all this here, you got to show what you typed into the formula. And I'm telling you, it's better to show what you typed in, because if you get the wrong answer, then we know when we're scoring it, oh, they must have just typed it into the calculator wrong, but they knew exactly how to substitute it into the formula. Okay, so I'm going to first start by writing the formula. And again, you do not need to memorize it. You just need to go grab it from the formula sheet. And what do I need to put around every single number? Parentheses. So negative parentheses what? 16 plus or minus parentheses 16 squared minus 4 times or parentheses 4, and then another set of parentheses 9 all over. Weird thing also, put the fraction over the whole thing, not just part of it, the whole thing. And then 2 times either adding or subtracting. You have to do both. Remember, how many answers are we usually going to get? 2, okay? And then what's going to go in this last parentheses? 4. Okay, here's what I believe is the most challenging part because of the amount of things that can go wrong when we type it into the calculator, but we're going to try. I start by getting what? Alpha y equals a big fraction. Then, so important, the formula starts out with what? A negative, not a minus sign, negative, which is next to the decimal. And then I start typing in what I see, so parentheses 16. Sometimes not, but it's better to have them there for when it does count. Right, so I can only do one at a time. So I usually start with plus. How do I get the square root symbol? Guys, listen up. Second x squared. I'm almost done. This is the last thing. I actually am proud of myself with how well this is going in terms of time. Okay, and then what? Squared minus, big, important, I switched to a minus sign now, not a negative. It's in the middle of a problem. It's a subtraction symbol. You can never start out something with a subtraction sign. Okay, minus 4 times 4 times 9. And then in the bottom, 2 times 4. Sometimes they might say round to the nearest tenth, sometimes hundredth, sometimes they may say exact value, which by the way, we did not get the exact value because again, we're missing some decimal points. By the way, what type of number is this? Who said it? Somebody said it. Irrational, okay? Yeah. Common question, whether the solution is rational or irrational. So I'll write that down in a second, but that's not my only solution. How do I get my other one? So when you go up and highlight this and just hit enter, it makes it so you don't have to type the whole thing in again. And then I just got to hit over to my, and hit minus. And I get negative 3 point, I'm going to round to the nearest hundredth. So I'll do negative 0.68. So x equals negative 0.68. And x equals negative 3.22. Wait, 22 or 23? 3.32. Sorry, my bad. 3.32. 2 answers. I think that's it, right? Practice with a smiley face. You now have the next 25 minutes to practice. Make sure you practice. There was a lot that we went over, okay? If I went too fast, I apologize. It was my goal to try to be faster than Mrs. Kovac. I'll leave that up there for a second. Yeah.
He's about to kill himself. We're about to get angry or hurt somebody. I need to stop talking. Leave him alone, bro. He minding his business. Leave him alone, bro.
Okay, so we have short hours, fried coffee, additional funding.
Leave him alone, bro. Leave him alone. Bro, leave him alone, bro. Leave him alone. Y'all some goddamn bull. Leave him alone. My son, he's doing his work.
Oh, yeah, he's very able to.
Don't even talk to him. I don't want to answer that. I'm not trying to hurt you.
So we know that at most, you can send that. You've done more than that. You gotta get lots of solution after lots of so either
Additional usually it's where the additional that you like actually bring to each ride. So what's a one-time initial fee? Yes,
Terrible.